Yes, I believe that is correct regards to the muting, but you can put questions and comments in the chat and they'll get picked up and fed through. Couple of minutes. Okay, good evening, everyone. We've got quite a bit to get through, so I think we should kick off. It is 6:30, and welcome to the MOD's Professional Engineering Institutions Defence Lecture. It's hosted by BCS this time, with great support from Royal Signals in making sure that this happens. Unfortunately, we're not all together. This is a fully virtual event. We had hoped we'd be seeing you in London this evening, but I'm afraid the train strikes have rather put paid to that. And I think it was a very sensible decision to, rather than postpone it, we've had enough postponements over the last few years to just get on with it and do it virtually. So that's what we're going to try and do. You will be muted, I believe, but if you want to put any comments or questions in the chat, the team will be picking those up behind the scenes, feed them through, because we will have a Q&A, a live Q&A at the end. We've given very generously, I think we've given the speakers only 15 minutes each to cover some quite intense and detailed topics. I know they're going to do their best, but if there is any time after end of each of those sessions, we'll do some questions, but I really don't think there will be. But save your questions if you want to towards the end of the Q&A. We hope to be all wrapped up by 8:30. So, without further ado, the first job I have is to ask John Higgins, who's the immediate past president of the BCS, to say a few words. Over to you, John.
Thank you very much, Adam. Good evening, ladies and gentlemen. It's not often that I'm genuinely pleased that the current president's unavailable to take on an engagement, but I really am tonight. I was the president of BCS, as Adam said, until earlier this year. But before that, in maybe a few years ago, I was the Director General of Intellect, what is now Tech UK, and that conferred on me the great privilege of being a member of the Defence Industry Council, and Intellect was very engaged in what I fondly remember being called C4 I-STAR activities with the MOD at the time. So it's great to be back in this particular field. I went on from there to become the Director General of Digital Europe, which represents the tech industry, and particularly the tech industry's points of view into European policy making. And of course, over the last few years, AI has very much been front and center of the discussions in European policy circles, probably one of the most interesting digital policy developments that there is. And so I've been following carefully the developments of the EU AI Act, and I'm also involved in some aspects of that to do with compliance and assurance. So I'm very much looking forward to the AI aspects of tonight's talk. It's interesting, of course, also that BCS has its own AI group, which when I was president celebrated its 40th birthday. I'll say that again, 40th birthday. It's been going 40 years. So, but I'll come back to why I'm pleased about the actual topic in a moment, but just a little bit about BCS and MOD. So BCS has 60,000 professional members, and one of our primary aims is to promote the importance of professionalism, professional standards, and having a professional approach. And we think the time is really right to be promoting that, because certainly over the last few years, trust and confidence in the role of digital, as you know, has been suffering a little bit through a variety of things I don't need to tell you about. And developments in AI and machine learning are to some extent only exacerbating the fears that are increasingly widespread in society. And we really believe at BCS that one way of allaying those fears and dealing with those concerns is to show that people who are working as practitioners in our field adhere to the highest professional standards. And by that we mean they have ethical values, they have superb levels of competence, and they understand that they're accountable to wider society for the actions that they take. And so it's really very pleasing to see that MOD believes that too. And to me, the evidence of that is that there are some 1,800 professional practitioners in MOD who are members of the BCS, and that's across many different aspects of the MOD, whether that's Defence Digital or Royal Signals, the services, of course, Army, RAF, and the Navy, but also DE and S, DSTL. You'll hear people from DSTL tonight. So it's great to see that, you know, MOD is a partner in professionalism and demonstrating that real commitment to professional standards. I think that's really important. But let me return briefly to why I am particularly interested in tonight's topic. So being interested in AI over the last few years in various roles, I came to belong to a group of a small group of interested people who are actively engaged in the implications of AI for society and the economy over the longer term. I've sort of bit of a ragbag of a group, really, from all different backgrounds, but one of the people who I admit I haven't seen very often at the groups, but one of the members of it is Stuart Russell. And Stuart Russell gave this year's Reith Lectures called Living with AI. And when I listened to the lectures, I thought for most of the lectures, for me personally, I learned some small new things, but mostly they were well-exercised arguments, apart from in one area, and that was AI in warfare. That was really eye-opening. So it really is with much anticipation that I hand over to Major General Collier to give us a proper introduction to what an event I'm really looking forward to, and I'm hoping that I'm going to take Stuart Russell's AI in warfare and learn a lot more, really get into the detail. So Major General Collier, please introduce properly what we're going to be hearing about tonight.
Hey, thanks, John and Adam, and all a very good evening. Yes, John Collier, I'm the Army's Director of Information and Chief Information Officer. It's thrilled to be on this net tonight. And right up front, genuinely, many thanks also to the organising team for tonight's lectures. I think we've got, by any measure, an exceptional array of speakers, some of whom I and we all know well, but common to all at the pinnacle of their credibility and applied expertise. I think that's great news and a great lineup. And I might also, I think, comment right up front, John, to your point, just about the criticality of Defence's linkages with the BCS and associated and affiliated organisations. I'm thrilled myself to be a recent member, and I'll try not to bring the standards down. But important. I mean, these partnerships are really the bedrock for us of people, technology, of standards, and potency. As we in defence, amongst others, seek advantage in the security sector. And in this case, through the accelerated and responsible exploitation and development of technology. And as we often say, but sometimes don't match, at the speed of relevance. And from a military standpoint, I think it's probably fair to say, more than ever, I think, we couldn't do it on our own. That would not end well. And never more so, I think, as we navigate and seek to capitalise on our necessary ambition in autonomy writ large, where it's advantageous to do so. And I talk to that across a continuum to harness these technologies and concepts right the way from strategic insight, decision making, and right the way through down to the delivery of tactical effects at the tactical edge, as we often call it. I think it's also good timing for tonight's lectures and discussions, but a week following the launch of Defence's AI strategy, and that came also with an accompanying policy statement on our ambitious, safe and responsible delivery of AI-enabled capabilities in defence. I would like to pretend that was the timing was deliberate, but that would be pushing my luck and also the truth, but nonetheless, a really timely event as the MOD's approach to autonomy and its constituent concepts and technologies are defined, avowed publicly, and certainly I think provide a helpful starting set of rails from which we look to accelerate. And I think this is very helpful, very much so. So in terms of turning to tonight's lecture, I think it might be useful to comment that the way that we are currently employing AI and the way that we look to accelerate its use, that there might be some loose parallels, and I definitely think advances, from the way we thought about cyber 20 years ago, accepting the profound differences between the two areas. But I think there's some commonalities, and I think we're better set. In cyber, certainly we, as a defence, we knew about the potency instinctively, we knew about the potential, but we spent a very long time, and I'm talking a measure of years, debating definitions. We had long figure of eight debates, perhaps futile, about who owned cyber. We talked about cyber as an ends and less about ways and means. And in worse days, we sort of talked, give me a box of cybers. I know it's good, just give me a box of cybers. Show me the red button. And by the way, what does it do? And I also think we instinctively self-censored of the day. I think we've moved on. So better news, I think, closer to tonight's topic, our allies and us and this community collectively have found ourselves in a similar space, but I think we're definitely a strong step forward and a much better approach. We've set out our stall, our level of ambition, an early framework for how we approach and think about autonomy, and a good starting policy wrap around it. So that's that I think feels like a better place to be than the anecdotes I just used. But we have got a long way to go, both building on the capabilities we've already got in flight, or in the locker, or indeed to accelerate. So I think, John, enough from me. Let's just say once again, genuinely very many thanks to the BCS and the Royal Signals and all the teams for laying on tonight's excellent gathering. And I, like all others, very much looking forward to hearing the insights and the challenge of these excellent speakers. Thank you very much.
Thank you, John's plural, for that introduction. I think we should move on. We've got a couple of minutes here, but I think we should move straight into the presentations, if we may. So if we can get an opportunity to get ahead of the game slightly, then I think we should take it. So the first talk this evening is from the MOD research team, and we're delighted to have Geraint Evans, I'm hoping is on the top there. It's just taken on my thing. I believe it is. He is there, and he's able to move us on with the first of tonight's presentations.
Okay, thank you. Good evening, everybody. Geraint Evans. I'm formerly of the Army. I formerly worked for General John in delivering the presentation I'm about to give you now, but I have actually just recently moved over on retirement to the DSTL as a consultant. So this brief I'll take you through is how we applied AI to a real world challenge and the kind of issues we faced, how we overcame them, how those lessons have then actually been applied in defence, and actually mirror some of the best practices in industry and have in fact been shared with industry and academic partners also. Next slide, please. Okay, so I'll talk to you today about what's called the Enhanced C2 Spearhead, Enhanced Command and Control. Command and Control here is a vehicle. For those of you who are broadly familiar with the subject, many different staff functions have to be serviced. They allow different opportunities for AI. So this wasn't going in to say, we are going to improve command and control. It was, we have a number of areas where we could use the AI to assist in the command and control function. But it was very much a real world challenge. So we weren't actually doing this in a sandbox environment. It was something where we had a real user, a real deployment timeline to go with, real equipment, real data, and we had to put it together in fairly short order, conscious of the fact that this was ahead of the strategy release. In fact, many of the lessons from this actually helped inform the strategy development and the statement of requirement for the new Defence AI Centre, which has been set up in parallel. Next slide, please. Okay, so why the spearhead? The mandate actually came from the top, and I think this is a key lesson. Senior, very, very senior sponsorship cascading all the way down through to the senior responsible officer and the program director and program team. That meant we were able to move rapidly and conduct that kind of pursuit of prototype warfare, because in many respects, we were breaking new ground. We didn't really understand from an MOD perspective, what was AI? Where did it need to go? What were the risks and the challenges? And so, but what we were able to do is explore new ways of working in doing so. So we used what was called the design-led approach. It's if you Google it, you'll see the Stanford design model or the Stanford method, a very, very good approach, particularly in Agile, that allows you to really rapidly ideate and bounce through different problems and so forth. And then on top of that, we then had a DevSecOps team, which we pulled together under MOD control. So we have an industry consortium that goes with it. Different SQEP are brought in as we need them. But it was done deliberately so that the MOD could actually own that requirement and not outsource. That's by no means in terms of disparaging the use of industry and collaboration with industry. What it allowed us to do is in this high risk kind of initial foray into where we were going to apply this in a real world situation, we had that kind of control and ownership of the problem space. It's a much higher risk appetite goes with it as a consequence, very much startup scale up. I know that sounds a kind of buzzword, but really it was. I could honestly say with that mandate and with the support I had from my seniors within Army HQ on behalf of Defence Innovation and elsewhere across Defence, our risk appetite was quite considerable, and we really did go after it as a consequence. In doing so, we were allowed to avoid the sins of the past in Cap Dev. I've seen some of the names in the attendees list. I know people have grown in at the Cap Dev and use of the word CADMID and so forth, but we were really able to just bounce around them or just move past them quickly because we knew what we had to get after. We learned by doing as a consequence. Next slide, please. So how did the spearhead view AI? Right, this is not a definition. There are 250 definitions of AI, if I recall correctly at the last count. Certainly going back to John Higgins' point about the REIT lectures, I was there as part of the MOD team, and Stuart Russell had his view of AI, very much tied around kind of drones and UAV. But in this case, what we had to do is strip all that apart, look at what the definition said. They didn't really help DevSecOps. So in our case, we just had to say, right, here is how we will approach it. We will actually remove the burden off the human and put it on the machine wherever possible. But in doing so, in the blue box there, these are recognized technologies in AI. So what we never did is we never went in saying we wanted an artificial neural network, for example. But I had use cases given me or requirements given me where the users said they wanted that, but they could justify why. What we did is we asked the users to determine what they wanted to do with the data. And the data was critical, and I'll come on to the reasons why in due course. But what I can safely say is from those 8 bullet points you got there in the blue box, probably the top 3 service the majority of requirements. And that is because the military trains a certain way, it's structured a certain way, it thinks a certain way. And as a consequence, by hitting those top 3 in particular, huge and considerable improvements were made initially. Then we started to go into more complex techniques with supervised learning, regression learning, and so forth. So ultimately, let the use case determine the technology. And I was guided by industry and also the DSTL, who were actually working with me at the time before I actually joined them. Next slide, please. So first principles. Fundamentally, we code as we operate. And that is key because that leads to the algorithm that you require. But that algorithm is part of the fire triangle: algorithms, architecture, data. It was originally promoted by Hugh Derwent-White, who was the MOD Chief Science Advisor previous to Dame Angela. But in doing so, going back to the users, define the data you require. What is it you want to do with that data? What architecture does it sit on? And that then allows us to produce the algorithm, coding as we operate. But in doing so, we had to blend different data sets together. Operational data, quite obvious in terms of where we're going to be, but reference data, the data that actually underpins some of our decision making based on operational analysis, lessons learned, metric tables, and so forth. That in turn gives the coders a kind of a really good feel for the parameters of what it is they're trying to write. It also allows a much more accurate degree of verification and testing and so forth. But equally, the architecture, the reducing the deployed size, weight, and power, it becomes quite critical in certain operation environments in defence, which I'm sure will be elaborated on in due course. But as a consequence, when that fire triangle came together, it allowed us to go back out to the users to make sure the use case was realistic. And then the steps in our DevSecOps, we'd have to take them through in order to build the trust that they needed. Next slide, please. So how do we go about doing it? Ends, ways, and means. So the end state for us was reducing that staff cognitive burden, as we said, but it was augmented intelligence. So we said that on the basis of the AI, because it's such a contentious, what exactly is AI? Can the machine think and act like a human, and so forth? Actually, we were augmenting that decision-making process. So from military parlance, improving courses of action analysis and the force generation, and then understanding the potential of entity intent, data, people, objects, organizations. We are data objects. We exist within this data fabric, this data landscape, where you can apply those analysis techniques to them to understand that, yes, this kind of entity here, it may be friendly forces, may potentially adversarial, they may be neutral. They can act and think a certain way. And it's being able to understand where the data comes from. So you actually start to structure around the coding platform. And that has a definite operational benefit because it starts to map reduce. It starts to reduce down the kind of, right, this is what I need to do. These are the decisions I need to make. The machine has already got the data preloaded, and I can explain how in a moment. We already have that information. We understand why that information has to be analyzed and interpreted a certain way. Now, that was done off end-to-end requirements management by making sure the users were very clear in the use case, understanding the outputs they required. We were coding as we operate. The data they required and we required had to be in context. It wasn't something we just randomly got. A lot of time, probably the first 6 months of the program, was actually finding the right data, the data we could trust. And I admit we had to take lawyers through it to understand, so they could be sure they were happy with the data content. Now, one of the things we also did is that we took a variety of commercial and military off-the-shelf COTS and MOTS products, and we did code and we'd only code anew when we had to. So if those COTS and MOTS products, with a degree of what I would call bastardization, couldn't service the requirement, then we would actually code in between the bits that they couldn't. But that requires some considerable strategic patience. Inevitably, people will see something advertised or briefed or demonstrated in industry symposium, whatever, not decrying what those services and platforms can do, but it's the use cases we were going after, ensuring that we could actually deliver against that deployed swap and architecture with the right data. The way we did it was microwells. Microwells are very good at a very good tool we found, and conceptually they've actually sort of landed in defense and have actually continued to grow. That you bound a problem, you bound the geographical area you're operating in, you bound the operational space. And that allows you to build data layers and data facets. And what you do is you start to put you almost put it in a box, and it's a multi-dimensional box that allows you can't see it, you can't touch it, but from a data management perspective, you understand the data that goes in and why it has to go in and why it has to be structured and cleansed a certain way. And then it's tested in what we call the information range, so real world test environment. So we actually avoided sandboxes almost immediately by going straight to the real world test environment, the real world equipments and so forth, because if it was going out in an operational deployment, better to garner the user trust by going straight to the crunch point where this would all come together. That data access against the use cases, because we got into the training continuum, the pipelines of the units who would be using it, so very, very early, understanding their processes, code as we operate, but getting them to build the trust, and then equally managing the expectation all the way through. Next slide, please. So embracing the realities. At the same time, we had to accommodate this. There's not as much AI as people would popularly imagine. I appreciate John Higgins saying that it's been around for 40 years. Yes, it has in various ways and forms. But the focus is very often been on narrow AI, very specialized area, a very narrow subject. Some of the questions, some of the very complex questions the defense has to answer require a much more general or broader sense of AI, which just isn't there yet. Hence why C2 had to be broken out across functional areas so we could determine the intervention point. That means there's no one size fits all. It's situation and context specific. And what we also determined in doing so is that it's very difficult to move AI between operational theaters in some cases because of the base data you use, because of the kind of operations and the decision making. At the same time, that's not necessarily a problem, because it could be there's bespoke solutions have to be developed around each kind of contingency plan of type of operation. But equally, many of the AI services available are analytics tools rebranded, as we discovered. And that means there's a degree of having to cut through the hype, understanding why that was being actually marketed, what gaps it could fill, was it suitable for a certain use case? Again, no one size fits all, no one size tool fits all. Equally, we had to be conscious of development pathways. Some commercial products are designed on unrepresentative data. In military parlance, that has a real legal and ethical use, because if that AI goes wrong, who is responsible for it? Is it the developer? Is it the MOD taking it on? Is it because the MOD is giving it a certain type of data? These are the kind of questions we had up front. And these are the kind of things we really had to unpick. We had a great legal support, great ethical support from across the service, and also from the Defence Autonomy Unit to get after these kind of problems. User engagement was key because we had to expose them to this, they actually get trust in what they do, but also making sure we could always go after that reduced size, weight, and power. To illustrate the point, many of the products we saw were designed to work on high-end data storage. On the bottom left there, I'm not sure, that's one of the big vendors, I'm not sure which one it is, but you can buy services that have been designed in that environment. What you see in the middle, that's what we had to work with. We had to put everything on that box that you can see. It's a very potent little server, but it had to be able to operate connected to networks, then disconnected if we lost the network connectivity for whatever reason. And then what we're able to learn from this is how we could get it onto the laptop, which you could see the key functionality onto the laptop you can see in bottom right. So for the military, we tend to turn things on its head. We can't always have the cloud access that we need, which has huge benefits to this kind of technology. At the same time, we have to work with the kind of irreducible minimum. Next slide, please. So the challenges as we see them from the program, so I think it's my last slide now. So these are kind of key lessons. There is a reality of fragmented networks across the service and so forth, and the domains. Defense is going after these, but in some cases you'll still have use cases which pull those fragmented networks together, and the available cloud hosting, the data access, security classifications come to environmental demands. At the same time, we're also acutely conscious of the fact that some of the AI can actually really benefit from those large internet barriers and the hyperscale public clouds which you can get, and that is an area where certain experimentation has already revealed huge benefits to be made, and there are risk balance cases in terms of where these can and cannot be used. At the same time, many equipment programs are already contracted against, so the intervention opportunities may be limited as a consequence. It goes back to that strategic patience and kind of management of expectation. And equally challenging the industry and academic claims. So I say this actually now being over in DSTL, that what we do see is an awful lot of ideas in terms of the research space that could or could not mature, but it's making sure they are done with an intelligent customer. So the customer's asking the right question, we know which bit of the research to go to. And that is a problem in upscaling, because if we move too fast with the wrong kind of vendors or wrong kind of base plan assumptions, things will go wrong. And I think previous equipment programs have demonstrated that this technology is not one you can easily do it with. Controlling the narrative around a pragmatic partner relationship, understanding that no single entity has all the answers, no single company, no single organization. We certainly didn't think that in the program, and it was really, really good to see that we had so much support across the other services, from Centre, from the Defence Autonomy Unit, from DSTL and industry. Ultimately for us, however, that fire triangle, it is non-negotiable. So planning any of these, what you see above, has to be planned around that fire triangle, making sure you have the constituent elements in place that will allow you to go after the DevSecOps we saw, and then also making sure it can integrate and be sustained, along with the focused collaboration. A clear end state goes back to the narrative piece. It was a kind of pastiche of we were transforming as we went, we learned as we went. The successes, they were announced by the government last year, they were publicly released through the MOD and also through DSTL. But for us, the lessons were based on a key point of what we see here in upscaling. Those lessons still remain. How quickly they're going to be solved, we don't know, but certainly it was good fun trying to find out. And I think that's my last slide. Yep. Brilliant. I'll take any questions if we have time, otherwise I'll save them to the end.
Yeah, I'm not sure. I had one, because we do have a couple of moments. I had one, there's something that you said about so AI in the private sector. Often when people are talking about AI in the private sector, big rollouts and sort of use cases that are currently live, turns out all we're talking about is customer services and chatbots, allowing people to get to the phones or allowing you to deploy phone. What do you think is the difference? What's the similar narrative in sort of military circles when everyone's talking about AI, but what in reality is being done now? And what do you think, how far do you think that could go in the future? Do you see what I mean?
I do, and I think this goes back to the point we raised. That's why we had to have a working definition. In fact, we got the chief science advisor to agree it, so that we weren't browbeating in terms of what do you define AI to be. What we found was the easiest answer, mindful of the challenges I said in upscaling, was just to simply say that you have a certain technique or a certain technology which or algorithm which allows you to solve a particular problem, and it may fall under the umbrella of AI, and there's all those different kind of approaches which you can use thereafter. And the way I approached that was that we had very clear requirement setting, being able to juxtapose that with what industry were proposing, or even what the DSTL were proposing, marrying them up and saying, right, that is probably the best solution and best fit, and trying to avoid using the word AI. We had one commander said, right, what's the AI in this? We're the best one in the world. He didn't need to know. What he needed to understand was the output Did the output service his requirements? Yes, it did. Could his users and his staff literally strip back every single stage of the production process? Yes, they could, because we could audit it. And then did it build trust? Yeah, we did that by going through the chain. So I think there's a kind of, what we found is there was almost a degree of, there's an awful lot of narrative, there's an awful lot of hype, there's an awful lot of marketing and business development which uses AI in that kind of context. It's just having the confidence to challenge it, to say, right, well, actually sometimes asking the company, what is the AI? And we've actually had BDs unable to answer us because they themselves don't know. But if you part that to one side and say, is that technology solution suitable to fix the problem, then you're onto a much better footing, we would argue.
Thank you. Yes, I think I get that. We've had another question, which I think we'll save towards the end, regards to regulated environments and talking about the example of aerospace. But I guess in the military, people are trained to make decisions based on their understanding of where that information comes from, and AI is just another problem. So what I mean by that is even the Foreign Commonwealth officer, an ambassador, understands where different intel is coming in, and therefore what is more trustworthy than the other. And AI has got to fit in there. People got to understand where's the human element and where's the AI element, and actually does that give them a better or worse understanding of the bigger picture. But we're getting into the depth of it, and it's time to move on. So thank you very much to Grant, who will be speaking to him later on in this evening for Q&A. And now we're on to Nick Colosimo. No, that's not right. I wrote it down.
Colosimo. Close enough, though, Adam. Close enough.
Colosimo is what I wrote down.
Colossus, the Colossus of Rhodes.
That's what I was thinking, but I won't continue. Nick, over to you.
Wonderful. Thank you. So, yeah, if you could move on to next slide, please. Wonderful. Right. Good evening, everyone. So I'm going to be talking about the future of AI, which is always going to be a bit of a challenge, but it is from a past position of demonstrating a whole range of autonomous systems over the last 20 years, all of which contain various forms of artificial intelligence. So I've got a lot of slides. I've crammed it into 15 minutes, but there will be time for some Q&A and offline discussion. One of my colleagues described the slides as animated fractal microfiche, right? So I'm not sure how many people remember microfiche, but there we go. But you'll be pleased to hear that I've removed the animations, so a temporal improvement as opposed to a spatial one. So at least that is a start. So next slide, please. Next slide. Wonderful. Okay, so futurism. So first, we need to start with the future. How do we actually predict it? So I guess over the last decade, since my former team really started this, we've conducted a structured and systematic process to predicting the futures, and that's plural because we don't really know which future it will be, but the trick is not to be too far wrong and try to get to a position of understanding the so what and then the do what, the recommendations, if you will. So we watch, we read, we perform deep dives and conduct independent reviews, and we leverage pretty heavily from MOD's think tank, DCDC, and its output. So thank you very much to General Mitch Mitchell, formerly, and now General Daryl Amison for all of that. So we cover the whole of PESL, the political, the economic, the sociological, technological, legal, and environmental. Next slide, please. And again, please. Wonderful. Okay, so state of the nation, what do we know? Well, we know that AI is a key enabler for robotic and autonomous systems, but at the core of all of that is systems engineering, architectures in particular, as Geraint just mentioned just earlier. So if you want to develop something, deploy something which is assured, effective, and safe, then you have to start with the systems engineering and not the AI, and architectures is absolutely key as part of all of that. We know that AI is outperforming human experts at some very narrow tasks, and we'll come on to that in a little bit of time. And adversaries are leveraging AI. So Putin's past remarks, so he said something to the effect of the nation that leads AI will rule the world. And we also see a lot of scientific papers coming from China, very large quantities and very large numbers of PhDs as well. In fact, probably more PhDs than anywhere else in artificial intelligence and autonomy. And the quality of that work is improving too. So we have a challenge there. We're generating more data from sensors, both internal and mission system related sensors, looking at the outside world and things going on, if you will. And so because of that data, we are now having to move towards AI at the edge solution because of communications bandwidth. And noting also, as Grain alluded to just earlier, we don't always have communications assurance, and therefore we still need to do things at the edge or locally, which could be at the front line because we can't reach back to the cloud. So in defense, autonomy represents a solution to many challenges, as we've already gleaned, certainly the C2 angle just earlier, but many more as well. And I think everyone is familiar with that particular list. So next slide, please. And again, please. Okay, wonderful. Right, here's the microfiche. So there are a number of key issues, and I have picked on artificial neural networks in particular in much of this presentation, but the general principles also apply elsewhere. So one of the issues is opacity, ergo explainability. So how exactly do we explain how this thing is actually working, how it's come to its conclusions when you've got this vast network of many nodes, many layers, perhaps millions or even billions of parameters? How do we unpick that? And this is not normally how industry verifies and validates software, right? Because we've hand-coded it, generally speaking, we know what's in there, and we can apply formal processes to understand what it is that we've got and that it does exactly what it should do on the tin. So why did an artificial neural network come up with the answer it did, and why did it go wrong? How do we unpick and undo all of that? There are some major challenges in there, and whilst there are one or two solutions, they're not terribly good solutions. Brittleness, ergo reliability, is another issue. So adding specific noise patterns to an image which are imperceptible to a human can cause classifiers to catastrophically fail. So this is well known, demonstrated through generative adversarial networks, as they're called. And the reason is because these classifiers aren't working the same way as our brains work in terms of binding features together to work out what a thing is, because it has something that looks like an ear or something that looks like a wheel, and and the combinations of those features give rise to a classification in the human sense, right? But not necessarily in terms of the machine. We'll come back to that shortly. Non-determinism, ergo predictability, so complex autonomy, multiple self-organizing, self-adapting assets that have behaviors which are now a very strong function of the operational context, the mission, the environment, and the constraints. And if it's self-adapting or self-learning, if you will, then they've not been designed by industry anymore. So who's qualifying and certifying them? Because they've been partly designed now by the operating environment through use. AI, we know, is greedy as well. So many popular classifiers requiring thousands to millions of images to train. Reinforcement learning requiring equally high numbers of iterations in order to home in on the right answer. And so there's some questions for defense. Does defense have all of that data, curated data? Do we have a sufficiently high fidelity AI gym and related environments to train deep reinforcement learning algorithms? That's a question, perhaps. And compute power for training for many of the leading edge AI algorithms is outstripping Moore's law. So in other words, we're seeing a doubling every few months versus a doubling every 2 years associated with the hardware aspect, which is ultimately Moore's law. So next slide, please. Okay, so why does this give us an issue? Well, it gives us an issue from a human-machine teaming perspective and human trust in a system, which is ultimately related to reliability, predictability, and to some extent explainability, albeit you don't always need explainability for a number of reasons. It depends upon the circumstances. But the general trend has been that trust has been falling, whilst the performance of these algorithms against very specific tasks has been increasing, right? So there's been a bit of a trade-off that we've been seeing recently, but we've been applying AI in defense for decades, certainly as far as I can remember, at least 3 decades in any extensive sense. So it's not really a new problem, but we've tended to stick to solutions that we can explain and understand, right? And this is getting difficult with deep learning type models, whether it's reinforcement learning or neural networks, for instance. Okay, so what is important here, I think, is where we set our trust threshold, which depends upon the application and the context, because we need to consider the risks, and we also need to consider the need. And this is the trade space, and this is an operational trade space ultimately, which will manifest at the front line. So we've got to pick these algorithms very, very wisely, and we have to apply the systems engineering properly in order to make sure that these things are robust and ultimately they are assured in some sense. Okay, next slide, please. And again, please. Okay, so some trends. So affordable computing power increases and big data accessibility in commercial sectors is really what's behind the AI revolution in the main, I would argue. There's been some incredible achievements with that across a wide range of applications, often surpassing human performance in some instances, but obviously with caveats. And one of those caveats is that it's often quite narrow, it's quite tightly constrained, and the context is well known, the scope is well known, and so on. So in other words, picks on Geraint's point just earlier, that there are some challenges here with the wider challenge that we have in defence. There are also some retarding factors as well, which brings the whole sustainability of AI development into question, and we'll come on to those in just a moment. But it's not all doom and gloom. There are many solutions which are starting to emerge. So next slide, please. Okay, wonderful. So more microfiche, apologies. Right, processing power. Okay, so we've seen huge improvements in compute efficiency per electrical power and also volume, but the demand signal for training of AI is still outstripping our ability to keep pace with it through necessary hardware developments, i.e. it's outstripping Moore's law. Okay, the charts on the right-hand side relate to compute power, execution, not training in this particular case, and the vertical axis represents computational performance in or with reference to electrical power or volumetric terms, and we've got year on the horizontal axis. The key points, I think, from these charts is the red, yellow, and green conventional computing units, the CPUs, the GPUs, the TPUs, the von Neumann type architectures, and how they're trending, right? And where they will get to in time in terms of that particular cluster. In other words, we're not going to approach anything of biological significance for a very, very long time. So we need to understand what, first of all, the equivalence is between floating point operations per second and the right-hand vertical axis, which is in terms of synaptic events per second, and understand what that equivalence is. And so we made a bit of a guess at that on the right-hand side. So we may well be out by an order of magnitude, but it's still useful to look at that. The key thing is that we're going to need some wholly new paradigms in all of this, and that's kind of indicated by the blue line and the blue dotted line, and this is something related to neuromorphic processing, which we'll come on to in just a sec. Next slide, please. Okay, energy consumption, right? So hot topic, quite literally, for all of us on the planet. We're all concerned. So if you look at what's happened over a number of years, so 300,000 times energy cost increase in training AI between the dates shown on the right-hand side of the slide. GPT-3, which is a natural language model, so you've probably seen this generating all kinds of interesting texts, which read as though a human has written them from, ultimately very little textual training data. If that was powered from fossil fuel energy sources, it would have produced 85 tons of CO2 in its training. So the question is, who is optimizing and performing the accuracy versus energy consumption trades to avoid being wasteful? So is that extra 0.05% of accuracy actually worth another 10 tons of CO2? Right, so this is a really important topic and requires attention. Now, fortunately, there are some interesting papers out there which are listed on the slide. But imagine, I guess, from a defense perspective, a self-adaptive or self-learning system on the front line at the edge. Where is all of that energy going to come from? Are we going to deploy nuclear fusion reactors to power the training of artificial intelligence, or are we going to take a different approach? Next slide, please. And again, please. Okay, so solution catalysts. Where are some of the solutions? So starting first of all with neuromorphics. So I mentioned new paradigms in terms of performance per unit power and volume earlier. We can take inspiration here from nature and biological neural networks. And a bit of news, our artificial neural networks are 1 million miles apart from what happens in a biological neural network. The only thing that we share in common is the fact that we've got layers and nodes and connections, synaptic-like connectivity, if you will, and actually not an awful lot of that as it transpires, right? So the key question I think in this is how is it that something like a honeybee with under 1 million neurons, powered by nanowatts, in something the volume of a few grains of salt, can realize perception, flight control, navigation, guidance, communication, social behaviors, and a whole lot more? We are missing something fundamental in the existing AI approaches, particularly around artificial neural networks. Now, spiking neuromorphic solutions can start to bridge this gap, as we've seen some developments here, such as silicon-based neuromorphic devices. So in other words, the neural network is on the chip, right? It's not in software per se, but it's embedded in a hardware sense on the chip. But can we also evolve and let these networks emerge as well as train them? So in other words, we're not designing this particular chip, but we're growing this particular chip. We're growing, for instance, such as Professor Lee Cronin's work at the University of Glasgow, growing a polymer neural gel brain, which in principle could surpass silicon devices and biology in terms of that performance per unit swap. In fact, neuron sizes which are 1 to 2 orders of magnitude smaller than what we even find in biology. Now, that would be truly a game changer, if you will. Next slide, please. Okay, combinatorial AI. So one of the problems with most artificial neural network image classifiers is that they're really pixel or pixel cluster correlators through a data set. And you can kind of see that in the example on the left-hand side with the husky. The correlations that lead to the classification of it being a particular animal, in this case, is it a husky or a wolf? Well, it's misclassified as a wolf because, the image data set with all of the labels that said it's a wolf, they all had, snowy backgrounds, let's say, right? So in other words, what is the image classifier really doing? It's performing a pixel correlation, but it isn't really saying these are the right features that make up this particular type of dog. And they are in the right places relative to one another. So this is where architectural approaches come back in and maybe the answer to this. So combining different forms of AI together to achieve the best of each world. In other words, not going to an ever larger convolutional neural network as being the answer and trying to brute force a solution out of it. So top right hand side is something I've been working on and recently demonstrated for defense applications, where ultimately the classification is not performed by the neuromorphic element, the deep learning element at the front end of this, but ultimately by different models, a geometric and a symbolic model, which takes in input about particular features from the imagery. And I guess ultimately we're seeking a solution to the feature binding problem as per Dr. Simon Stringer's excellent work at Applied AGI in Oxford, which may even solve some of the previous problems too. So how is it that honeybee was able to do all of those things? It's about complexity and it's about dimensionality in the network. And if you add the time dimension into that, this is where a whole range of interesting things starts to happen. So, of course, this isn't just about image classification and neural networks. It applies to many other forms of AI and the machine learning subset as well. Next slide, please. Okay, wonderful. Quantum computing, right? So this is one of these buzzwords. I think if you put these words within any kind of bid, you've definitely won it. As along with genome and artificial intelligence, but they are becoming a reality now, and we might describe them as massively parallel optimizers. And it should be obvious here that, well, if you've got an optimizer of some description, then that ought to apply to AI, especially machine learning applications. So whether that's deep neural networks, deep reinforcement learning, search and optimization techniques, and a whole lot more. Indeed, you can already explore much of this online through various folks' quantum computers, which are being used for machine learning applications, and Google is a case in point. Interestingly, IBM's upcoming 1000 quantum bit or qubit quantum computer may be able to represent 200 orders of magnitude more states than there are atoms in the observable universe. That should be food for thought. Imagine what you could do with all of that complexity. And quantum computers aren't necessarily limited to large shielded rooms either, with big dilution refrigeration, stalactite type devices, the big gold things you see hanging down from the ceiling in many of the images on the internet. But there will be ion trap and optical devices that operate at room temperature and probably in the size of something akin to a suitcase, and probably in the next 10 to 15 years as well, and therefore edge-based applications of quantum computing is not really unreasonable, I think. Next slide, please.
You have to watch your time as well, Nick, please.
Yeah, last slide. Next slide, please. Okay, wonderful. Right, so what does all this mean? Well, we're not limited to smarter robotic and autonomous systems. Obviously, all of this aids with that. It means we've got greater form factor freedoms. We've got a wider application scope and potential for lower cost and hence greater capacity, combat mass, if you will. But ultimately, AI applies across the whole product lifecycle and the defense lines of development. It can aid in all of that, as well as being applicable in wargaming, in planning, in command and control, in ISR. It applies from platforms through to process and ultimately leads to faster, better decisions and actions as a result if we get it right. Next slide, please. And that's it. Thank you very much. Back to Adam.
Wow. Okay. Thanks, Nick. Well, there's I'm not going to sum that up. There's a huge amount going on in there. I would remind everyone, though, if you do have any Q&As that you'd like to discuss this evening, please put that in the chat, and we will try and cover it. I think what might happen is people want to reach out and talk to some of you and pick up some of this offline, which is, of course, not unreasonable. But we're going to move on. So thank you very much to Nick. So that was BAE. And some numbers in there, the largest one at the end, which was X+1, where X is a suitably impressive number, and it was suitably impressive. Now we're going to hear from Kirsten McCormick, who is Systems Engineer for General Dynamics Mission Systems.
Thank you very much for that introduction. And as you said, I'm Kirsten McCormick, Artificial Intelligence Lead and Systems Engineer at General Dynamics Mission System, and I'm based over in the Hastings site. We've had a lot of amazing presentations so far already, focusing on, what AI is and also the issues with AI. What I really want to do is now sort of focus more into the utilization of AI. So if we go on to my next slide, please, maybe two. Yeah, if we go on to the next one. Wonderful, thank you. So yes, so this whole presentation is looking at kind of broadening our minds a little bit about the applications of AI and also understanding the why of why we want to be using it. And, artificial intelligence, machine learning can be such buzzwords. So it's really sort of nailing that point as to why we want to do it. So if we go on to the next slide, please. Wonderful. So artificial intelligence, machine learning is very, very important because it helps us with two key factors, and that's both accuracy and speed. Now, in sort of the modern day, shall we say, these two factors are still incredibly important. So if we take, for instance, the war on Ukraine at the moment, they're going up against a force which has such mass of not only personnel, but of artillery, just absolutely everything. And they need to find some sort of advantage in other ways. Now, if artificial intelligence was utilized throughout the whole chain, processes would be able to be sped up. But not only that, the whole cognitive process, the accuracy of that would be so much more if we develop these in the correct ways. And again, when you're going up against that force, every single round, every single thing needs to be on point, and AI can really help with that. Now, that's kind of looking at the kind of very modern day, shall we say. If we then go into the future of the battle space, so now we're looking at having loads of unmanned assets. Each platform that's coming out has even more sensors. We already have burdened operators, and if we then suddenly have so much more data all coming back, it's going to be so hard to even make understanding of all of this data that's in front of them. And this again is where AI is so key. It can help you rapidly understand sort of this copious amounts of data to aid the operators in many different areas. And the whole key of this is really to have that security of operational advantage, and that's being done by reducing that stress on them, and also having that speed and that accuracy within the decision-making processes. Now, one point that I'm not going to deeply delve into at the moment, but I think it's a topic that often gets overlooked, and that's counter AI being as important as development of AI itself. And what I mean by that is, if two sides have exactly the same capabilities, you're on a level playing field. However, if one side has the capability to either trick the AI or to disable the AI, they suddenly have an insane advantage over the other. And I think we often, and myself included, we get so excited about the possibilities and the different ways that artificial intelligence, machine learning can help, that sometimes actually countering AI can get overlooked, and it is just as important as the developments themselves. So if we go on to my next slide, please. Wonderful. So as I said at the beginning, what I really want to do is start having these thought provokers. I often think that when we talk about artificial intelligence, we often think of visual domain. So that image recognition, detection within video, and this is an insanely important area of research, and it will provide so many benefits in the future. But it's not the only area that it can be applied. So the image you have in front of you is even just a few applications it can be applied to, but we've got predictive analytics, so looking at the health management, that's a key area that AI can go into. We've got that information extraction, speech to text. And even when you think of things such as the planning, the scheduling, and the optimization piece, if you think about the combat estimate process, those sort of 7 questions that need to be answered, the first 2 are all about understanding the enemy population and things like that. AI could be implemented there to speed up that process and potentially even have that accuracy, picking up patterns that we may have overlooked because you're in such a stressful environment. It may be overlooked, but it would be able to help you and to guide you into potentially a new way of thinking, which may give you that advantage that you may not have had otherwise. So my next few slides are looking a bit more at the research that I've been conducting, again, just to try and show you what sort of areas we've been looking at, to maybe get those thoughts going in the back of your mind. Think of the use cases that you may have experienced or heard about, and really start to think about that. So if we go on to my first slide, please. My first slide, next slide. Wonderful, thank you. Now these presentations were all based on AI to help sort of robotics and autonomy on the battlefield. And that's very much what my first piece of research that I'm going to be talking about on the left-hand side is all about. And this is looking at the MUMPT scenario, so the manned-unmanned teaming. So if you've got a single manned platform, and you have either a swarm or multiple unmanned aircraft, you're not entirely sure of their location, their load, whether load needs guidance. All of these questions need to be answered before any decision about sort of a mission can be answered, really. And again, if you suddenly go into a high threshold environment where you have to make these very key decisions, how are you going to be able to decide which one should be delivering what payload? Will it need guidance? And this is what this research was looking at. And what I would like to say at this point as well is these are all decision aids. This isn't looking at autonomy at this point. It would be saying this is the best advice, shall we say, would you accept or not? It is then the operator's choice, but it's narrowed down all of these possibilities to provide with one single answer. So the next piece I'm going to be looking into is the situational awareness characterization. So this is quite different from that first piece, and is actually looking at tactical data links on tactical tracks coming in. And actually trying to figure out whether potential formations are emerging and the purpose of these to provide that awareness of what's happening overall in the environment that you are contained in. And then you could make that informed decision based on what you know. Now, for instance, if you had tracks coming in saying, you know, you've got a motorized rifle squad, then a BMP, and then another motorized rifle squad, at that point, the AI could be like, well, actually, this looks like a motorized rifle platoon, which then would be like, well, that's often a defensive formation. And even that gives you so much information about what's happening and could really benefit it overall. So if we go on to the next slide, please. Thank you. The final piece of research I'm going to spend a little bit more time on just because of the similarities that it has to network reconfiguration and network recovery. So this piece was looking at dynamic reconfiguration, and it was seeing whether these configurations could change during flight based on sort of the situation that it's in, and also for flexible failure management. But what I'll do is I'll go on to the next slide to explain it a bit further, and hopefully you'll then see how similar it could be and could be applied to the network reconfiguration and network recovery piece. So if we go on to the next slide, please. Wonderful. So for those of you who don't know, within aircraft, mission systems usually have a single fixed configuration that has pre-assigned internal routing for the bandwidth. Now with sort of these ever-changing complex scenarios that are happening, having that very fixed approach can be not great, especially if there is battle damage. Once that, I don't know, application is gone, it's gone. Now, the ability to actually internally prioritize this bandwidth, it could then bring it up on a backup. So you could actually regain that capability. Now, it was after this research, we were having discussions, and we realized that there was a direct parallel from sort of this migration from statically planned networks to that adaptive network. So for instance, networks are often planned out in advance, and if the adversary then takes down a link or intercepts it at any point, it then takes a lot of cognitive processes to actually figure out which route is now best, or maybe the information doesn't get over until it's been recovered. So the ability to have this dynamic network reconfiguration would be able to select a different route, a different link. It has so many different possibilities. Now, obviously, this would need to be contained in some rule-based. You wouldn't want confidential information going on a public sort of Wi-Fi or 5G or something like that. But still, having that adaptive network would be able to ensure that priority information is transferred from A to B, even in those contested and degraded environments. So if we go on to the last slide, please. Thank you. So I'm not going to go too fully into this because our next speaker is much more of an expert in the fields of ethics, but it's always something that I want to just bring to light. Obviously, with all of this research we are doing, we need to be very considerate about the issues with utilizing AI in defense. So we need to look at the safety, security, ethics, where we get the data from, how do we gain trust? And there's lots of ethical guidelines out there, and with the strategy being released, and as it's been explained in the previous presentations, that there is now becoming this sort of almost work pattern to follow through. So this is really key for us to make sure that during developing this AI, we are doing it safely and ethically. So then when it comes to deployment, we are transparent with the entire way that we've developed it, and it is more likely to be trusted. So with that, I'll leave the proper ethical work to the next speaker, and yeah, back to you, Adam.
Kirsty, thank you. That was fascinating. I particularly like some of your sort of actual examples, real world examples of some of the applications of AI. And I know we're going to move on to ethics now. So topic, one of the things I'm fascinated about with ethics is the unintended consequences of our actions, which is often where the sparks fly and amazing things can happen, but also potentially where the most dangerous things can happen as well. So we'll probably keep that in mind and hopefully have some more questions around that in the Q&A. And I will move us on, if I may. So the last of our talks this evening is Professor Peter Lee, Professor for Applied Ethics, Director of Security and Risk Research and Innovation at University of Portsmouth. So thanks to Kirsten. We'll speak to her again in a moment. And now over to you, Peter, who I believe is on, it's a significant anniversary, but is with us nonetheless.
Yes, today is my 33rd wedding anniversary, and I tried to reclaim some moral high ground by preparing dinner before this lecture. So delighted to be with you. Could we have the next slide, please? I'm going to be looking at some of the challenges for defence as we look to operationalise increasingly autonomous systems. The focus is often on the weapons element, but of course it applies to every system in a whole range of ways. And if I could just say a little bit about a couple of things I'm involved in, it perhaps helps you to understand where I'm coming from. My background, I was an Air Force chaplain from 2001 to 2008. My doctorate is in war studies, ethics in war, and from there my interest in ethics and drones, Reaper, moving on to autonomy and AI over the years. That's on the academic side, but I started with an engineering degree, so I have a fairly wide range of interests. And just in the last couple of weeks, I found myself at an event run by the Engineering and Physical Sciences Research Council, looking at trustworthy autonomous robotic systems for defense application. And so I'm actually involved in developing a program looking to use AI to enhance frontline triage and assist medics who may be under fire and without CASEVAC. So I've gone from not just being a theorist, but I'm dipping my toe back into the world of engineering, and in between I taught ethics at the Royal Air Force College for 9 years. So I like to think I bring a breadth of perspectives, but a deep passion for how military personnel in particular, in the moral component of conflict, how military personnel make decisions to deploy weapons, to use lethal force, often with inadequate information, without all the resources we would like, certainly not enough time, and with terrible consequences if they get it wrong. So I'm very interested in the part that AI can contribute to that. So in this title, next slide please, which looks at tonight's talks about autonomous systems, I think I'm going to speak more to the systems part, which includes the people who operate it. Previous speakers have touched on this question of automation versus autonomy, and I think none of us want to get bogged down in terminology, but on the autonomous side, there's a degree of self-learning, there's a degree of self-enhancement. on behalf of the AI-enabled system, whereas automation could be anything from your washing machine to automatically taking off and landing an aircraft. So with all of that in mind, how do we use this technology? How does it come to be deployed? Next slide, please. There are a number of challenges that have been set out already. I'd like to get a point in my remaining minutes to give you some examples, but the human is the limiting factor in much decision making in both active combat situation. So if any of you, like me, have seen the recent Top Gun film and are old enough to have remembered the first one, regardless of the Hollywood version of that kind of combat and all the camera work, at the core of it is still John Boyd's OODA loop: orient, observe, decide, and act. How do you make a decision quicker than your enemy and do it in a trustworthy, reliable way, especially with increasing amounts of information you're coming your way? So we also have operational environment is changing. Ethical challenges are continually updated and changing, but humans they get tired. There are some like me who are highly empathetic. I feel too much pain. I take on other people's concerns, which I think made me a good chaplain for a short time. But you can't live like that. But equally, you can't have people who have no empathy and recruit psychopaths to your armed forces. I believe you need human beings who are experiencing the full range of emotions when they are operating, especially weapon systems in war situations. The information process and overload has been better expressed by previous speakers tonight. But one thing that doesn't go away and won't go away is responsibility and accountability. I've used those two images left from a Reaper ground control station, where I've done significant research over the last 5 or 6 years, partly for a book on that topic. And then on the right, the Combined Air Operations Center, where you can see so much information and, you know, and 100 people on the floor watching a crew who's performing manually some ISR, intelligence gathering, surveillance, reconnaissance, or carrying out a lethal strike. And in those situations, it's fairly clear who's responsible and who can be held accountable. Next slide, please. But AI will and increasing autonomy will start to shift that calculus. Now, the UK has said, very cleverly and slightly disingenuously, that the UK does not intend to deploy fully autonomous weapons, and I could put quote marks around that because that's what the minister said in Parliament several years ago now. But what does fully autonomous mean? It means that if you don't have anything that matches human equivalence, then it's probably not fully autonomous. So it does grant license to do almost anything with autonomous weapon systems. But when you increase the autonomy, where is the ethical decision making? Where's the responsibility? And I'm going to show you an example in a minute. Because at the moment, for remote air operations, and you could use the same for land or maritime or subsea operations, rules of engagement that have been used by fast jets over Syria have been the same as those used by the Reaper flying over Syria, but operated from RAF Waddington or Creech Air Force Base by the Royal Air Force. Other challenges include the ongoing discussions at the United Nations in Geneva, the group of governmental experts on lethal autonomous weapon systems. Candidly, that has been in stalemate for 3 or 4 years, just no one's willing to admit it. None of the major powers want to surrender any advantage. 80 non-aligned states want a ban on lethal autonomous weapons, and many states like the UK want to find a way ahead that autonomous systems can be used in a way that's both legal and ethical. So there's no international agreement and much complexity there. Next slide, please. But I'd like to take you back in time a little bit and look at traditional linear hierarchies, both legal hierarchy, command hierarchy, and ethical hierarchy. World War II, I'm going to stick with air power, which is best known to me, but of course this applies to all domains. So in World War II, you would have Winston Churchill as Prime Minister and Defence Minister, and you can just read down through the Chief of the Air Staff, Arthur Harris, Bomber Command, Bomber Squadrons, Bomber Crews, and Bomber Crews would release weapons and make the final decisions. Currently, the remotely piloted Reaper, which is going to have succeeded by the Protector with more autonomous elements in it, and certainly more potentially beyond that, the command chain looks very similar. The kill chain, to use a crude phrase, Prime Minister, Defence Minister, Chief of Defence Staff, all the way down to Reaper Squadron Commander and the Reaper crews themselves. And I've seen and I've sat with the crews many weeks and months of embedded research and watch them not only take decisions to kill and to fire and kill, say, an ISIS jihadist, but also take decisions to refuse a shot on ethical grounds, because you have a human who can make the judgment that, to give an example, a Taliban bomb emplacer drove out to plant a roadside bomb, but he took his young son with him and drove for many miles out into the night on a freezing night. And when the boy was going to the toilet a couple hundred yards away, the crew itself was authorized to kill the father, the Taliban bomb emplacer, which they could have done entirely legally, but the crew refused the shot on that occasion on the basis that if they killed the father, the son would die of exposure before dawn in this remote place. That is a very human decision. The father was killed a couple of days later, where they found him in isolation. But that kind of ethical decision making is a very human function by a crew who were very experienced. In introducing a more autonomous weapon system, most of that hierarchy remains the same, from the Prime Minister right down to the squadron commander. But the autonomous weapon system, it will still need an engineer to check the engines. It will still need if I'm thinking of a flying one, it will still need the avionics check. It will still need an armorer to hang the weapons underneath. It will still need signalers to make sure it's communicating with the rest of the world. It will need intelligence updates, programmers, coders, you name it, all of these. And so instead of having one final person, the Reaper crew or pilot, making the decision on using a weapon, there will be what I'd call a constellation of responsibility that shares this responsibility much more widely than has been the case until now. Next slide, please. There is if you get the slides, there is a link there at the bottom that can take you to an article that I worked on with 10 other international colleagues. But in terms of risk and decision making, bottom left-hand side of that yellow-orange line, if you have an autonomous Reaper equivalent flying surveillance over a part of Syria or Afghanistan, which is fairly uncontested airspace, really not with any concern about using weapons, you can delegate a huge amount of responsibility to the machinery and very little potential harm could come. If at the top right-hand side of that straight line, and it took a great deal of time to develop a graph that looks a bit simple, but it's not. If you still want to have a system that may target very senior commanders in very complex situations, or senior government ministers of an enemy state, or such as a defense minister or a senior general commander, or if in killing one of these key figures there is going to be collateral damage, at that stage there is likely still to be the need to refer to senior political leadership in the UK's command hierarchy. So there needs to be an ability to move between different levels of deployed responsibility and authority to increasingly autonomous systems, and back again in very quick succession. So next slide, please. So there can't just be one way of delegated authority. It needs to be highly flexible depending on changing situations. I spent a lot of 2020 working on a project for DSTL, looking at legal, ethical, and moral aspects of advanced weapon systems, and AI was part of it. And I spent an inordinate amount of time looking at many of the AI ethics codes that exist in organizations around the world, and came across this wonderful paper by Jobin, Lenka, and Vallena, who looked at 84 different sets of ethical principles for AI ethics. And one of the challenges for defence is, I'm going to look at the third one listed there, was of the 84 sorry, a question popped up on my screen, but I'll pick it up after. One of the 84 sets of principles that were found around the world in many kinds of organizations, one that came up 60 times was non-maleficence, now not doing evil. But what that is meant by many organizations is actually highly pacifistic. The act of killing is inherently evil for many organizations that use AI ethics principles. But in a military context, in a just war setting or ethics framework, actually killing another human being, for me, can be a highly ethical act. Human beings in the middle of committing mass murder, that's murder with 6 R's in Scotland, to kill that person and cease the murdering is an ethical thing to do. So defense doesn't have the option of saying, oh, well, we'll just have our AI not involved in the killing of humans. Actually, AI may require to be deeply involved in the taking of human life, but not, certainly at the moment, taking any final decisions. Next slide, please. And I'm running out of time, so I won't go through all of these codes and principles, except to point out the one on the top right hand side is the American Department of Defense principles. Next slide, please. And last week, these UK ethical principles were published, and myself and Nick are fortunate to sit on the MOD's AI and Autonomy ethics panel. Our names have just been published, and so we got to contribute this towards these principles, and they're going to challenge defense for generations, and time will tell how useful they are. But human centricity, it's not just that humans are important, but that from start to finish, and from the shooter to the target and collateral damage and everything in between, human considerations have to be taken into account. And you can read those in your own time. Next slide, please, later on. But just to get to the point of putting forward ethics principles is really key. I mentioned the distribution of ethical responsibilities. Again, you can read those later, except that they will be putting many people in an uncomfortable position that they haven't been in before, because they will now be ethically implicated in a way that the active pilot shooter saved them from. Next slide. And in any system, I'm going to suggest that 3 different ethical tools, there could be more, but 3 are needed. You still need humans who are going to conduct themselves in an ethical manner, and the core values of the armed forces are still going to be crucial to those who are operating in these systems and controlling and deploying these systems. And then there's consequentialist ethics. What's the outcome? That's where, in an AI system, predictability and consistency is really important, both on an ethical side and for a legal side. And then deontological ethics, process-based, rules following. So rules of engagement, international human rights law, international law, and so on. These will need to be used as well. And AI systems will need to learn how to flick between those second and third ones in particular, helped by humans, but that's going to be a real challenge. And I think that's me near the end. Next slide, please. Because what is needed in all of this is relevant and effective education and training at every level, from operators on the ground to those who sit around the cabinet table in Parliament, and everybody in between. And all of you in industry who may think that contracts protect you legally, yes, they may do. Ethics does not give you ethics, like law, does not give you immunity. You will still be ethically culpable, whether you're legally held accountable or not. So on that uncomfortable note, I will finish. Thank you very much.
Brilliant. Thank you, Peter. I've got loads of questions off the back of that, because I do think about sort of ethics in IT and AI and more broadly are as one of the areas that I deal with. But I'm not going to, although it is incredibly tempting when I get opportunities like this to just have a conversation that I want to have with all of you, I am going to refer to the questions that have been coming in. So I'm just going to pull them up now and go through some of them. So I've got some specific questions for each of you, and then some general Q&A ones. We'll we'll see how long we keep this going. I'm going to definitely close by 8:30 at the latest, but we might go before then just to see how we are, because I know there's going to be some follow-ups outside of this as well. Great. What are your thoughts on using AI in regulated areas such as aerospace, more so given regulated environments tend to be very resistant to novel technologies? So AI in aerospace, moving in and out of regulated aerospace, in aerospace where there are manned and unmanned vehicles, and some are military and some are non-military. Yes, your thoughts on AI and use in those environments?
It's an interesting one because it does naturally relate back to seeing what Peter was saying then in terms of UAV platforms, for example. It's something which has been a kind of perennial point in AI ethics. Even if the platform is regulated, even if the system is regulated, if there is a justification for using a particular technology to exploit some of the data that is available, then it should be explored. I don't think we should necessarily just dismiss it out of hand. I think where you get into the kind of feasibility study is this something which, in terms of test and verification, the technical readiness may just not allow it, the integration may not allow it, or is it something you actually look at purely from a kind of outputs perspective? Is this something that's ethically acceptable, legally acceptable, and so forth? So I don't think there's a kind of clear-cut answer on this. And what we try to do when we were actually developing through the Spearhead and the prototypes, which the program is still running with, even though I'm no longer with it, is that you take each use case proposal on its merit. And they actually do distill that it's an end-to-end requirements question set. And I think as much as you want you want AI to work in these environments, you also shouldn't be afraid to say no. And there's an excellent article online which you can get, which is by Adam Drake, I think it is. I think it's called the AI BS indicator. The gist of which is, if somebody says they need an AI, they probably most likely don't. Or if somebody says they have an AI that will fix your problems, the chances are they haven't. And yes, that's a binary kind of way of looking at the problem. But what we encourage the users to do to create this entirely intelligent customer base is, if you are looking to integrate not just AI, it could be any other kind of technology which may assist in an environment which is very, very highly regulated and tightly controlled, particularly in terms of deployment into service in the military, then you have to ask yourself in terms of timescales, output, feasibility. That is not to dismiss it out of hand. I think as the AI strategy is released, you'll get much more coherent and erudite MOD planning series and responses from that, in terms of kind of sensible requirements that come through, which are feasible and can be delivered. But up front, it is a case of having the right community get together, sit down, look at the requirement, and distill it bit by bit. But certainly, I think the philosophy is, don't dismiss the use case out of hand straight away.
Yeah, absolutely. So the parallel that I see in private sector is the age-old conundrum around coding for autonomous vehicles on the road. Decision, are we going to have a crash with someone pushing a pram or an elderly couple, blah, blah, blah. But actually the real question is, does the system reduce by a significant factor 3,000 road traffic accidents or road traffic deaths per annum? And if it does, then the system is employable. But these are the ethical conundrums that these sorts of discussions throw up, which are, of course, incredibly interesting. Kirsten, there was one on the topic of the dynamic network reconfiguration of networks. Would it be feasible to scale up to a battlefield communications network with hundreds or thousands of moving nodes, or is this a step too far? So how scalable is that idea where you can reroute resources to keep systems to come back online?
Yeah, and it's a brilliant question. And I think it's the whole aspect of scaling up, I think, has kind of been touched on previously. I can't remember who said about it, but the fact that we're still at that very narrow form of AI. So I would say at the moment, it would be a step too far to do it here and now. However, in the future, it should get to a point where it is feasible to do so. And as it kind of relates back to the point that was just made, it kind of relies on that sort of technological process and sort of that advancements in the techniques and the technology and everything like that. But I don't think that it's out of reach for the future at all. I think it is highly possible.
Well, okay. Well, that's particularly interesting. I'm going to I'm going to roll a few questions together, actually, and try and paraphrase. Are we in an AI arms race with China, with Russia? And if we are, does their potentially different view or different standards when it comes to ethics give them a significant advantage in the battle space? That's to all and any of you would like to answer.
Can I start with that one?
Sure.
Because I over the last 8 or 9 years, I've been involved in a number of trilateral ethics discussions between United States military ethicists, Chinese military ethicists, who didn't come to the last one, and European Australian ethicists. And I've also done a big project looking at how Russia approaches it. I think whether you consider something an advantage or not, there's a subjective element. For example, let me be really crude here. Rape has always been a fairly effective and terrible weapon of war, and sadly we see it in Ukraine and in parts of Africa today. Would it improve the fighting morale of British forces to say we are willing to do that now? I suggest it wouldn't, because we have centuries of military culture that says that's abhorrent. So I don't think that technological advantage is necessarily a war-winning one. Vietnam, who had all the technology? The United States. Who won the war? North Vietnam. Not as simple as that, of course. But there's one fundamental problem. Someone else made a comment in chat about me having a very Western approach. Yes, if I had a whole term, I'd give you lots of approaches. But a Western approach, and this is what we have to work with in this country to consider the UK situation first. The Western approach is very individual-centric. So is there individual collateral damage, etc.? Is there an individual to take responsibility for pulling a trigger, an individual held culpable in law? There's been significant discussions in public about the European Human Rights Act just in the last week, because it interfered with a government policy about what was going to happen to migrants. And it was focused on individuals. In Russia, the primary ethical unit in the West is often and increasingly the individual. In Russia, it is the state. It is so the Russia, going back to Stalingrad and centuries before, the Russian state will sacrifice vast numbers of its people to maintain Mother Russia. And so it looks at morality in terms of the state. So bombing 10, 15 hospitals in Syria, or 60 or 70 in Ukraine, abhorrent in the West, violates the Geneva Conventions. But for Russia, if it supports the state political priority, it falls within an acceptable ethical framework. China slightly differently, state still prioritized, but a collective of the people. So the collective is seen as a higher ethical unit than any individual that helps to make it up. So yes, ethics is quite different in different parts of the world. Really good observations. Does it give us advantages or disadvantages? Both, depending on the situation, and maybe that's a discussion for another day.
If I could just add to that, Adam, as well. So absolutely agree with everything Peter has just said. You know, and at the end of the day, what warfighter wants a weapon that they can't control, a weapon that is entirely unpredictable, that, you know, there is no assurance that it will get the job done, right? And so, you know, so if you've got these systems which have those unpredictable characteristics, then, you know, maybe many nations wouldn't actually use them at all. So I think we've got to factor that in the thinking. And also I think we always have to make an assessment in terms of the risk versus the need, the military necessity, if you will, against the risk, you know. And in some cases, you know, as Peter was alluding to earlier, it can be unethical not to deploy an autonomous system. Right. And so, you know, we're constantly making these trades, and these are not a new set of trades. These are trades that warfighters have to make as operators and their command chain all of the time. And so AI is really no different. Perhaps there's a greater level of uncertainty if the autonomy isn't sufficiently bounded, but we can bound it, you know, and that plays into the earlier question about regulation in an aerospace context. So we have flown neural networks to provide data into an air data system 20 years ago, right? We've flown sense and avoid systems against real intruder test aircraft in a variety of head-to-head engagements 14 years ago. We've demonstrated man-on-man teaming 8 years ago, right? All these things are possible, right? And, you know, one of the traps that we fall into quite a lot on things like artificial neural networks is that we start thinking that we have to verify and validate the network. But in some cases, you can verify and validate the output. In other words, take an aircraft neural network-based router. What I really care about is not how it works, but whether I've got enough fuel to fly the route that it's generated, enough fuel to get to a reversionary airfield, that there are no waypoints out of bounds, that the waypoints are constructed in a way that they're within the performance envelope of the vehicle. So in other words, you can go straight ahead and put that sort of stuff onto an aircraft, right? It all depends, right? But there are many nuances in this, and it all depends upon the application and the context.
So if I can offer one point, which is actually from when I was serving, we had an ethics conference where one of the observations made is that, first of all, any force wants the equipment and the services to allow its side to win. Effectively, no one wants to. You don't deploy to lose. I mean, that is the one way to look at it. If you look in terms of those who will actually put themselves in harm's way. But then there were many use cases which were proposed where, quite frankly, the use of AI would not have raised an eyebrow, because it wasn't contentious. It ultimately boiled down to where lethal force would or would not be applied. And it's actually what euphemistically was called the Daily Mail test. Would it be something that would actually then be splashed across the front pages because the AI had gone wrong? And that's where the UK operates within the laws of war. There's use of bellum. Anyway, so there was, in terms of actually deciding the use case, it became very binary. This use case lends itself to the use of AI. This use case does not lend itself to the use of AI. And having a really good erudite LEGAD in situ, in fact, it was the RAS LEGAD we were using at the time in this particular conference. He was absolutely excellent at breaking down what this may actually mean in legal terms, which did then transpose itself across the kind of ethical debate because they were so closely tied. So I think it becomes very, very use case specific, but there's many different roles and functions you could put it in, which people just would not be overly agitated or bothered, because you can control the outputs and you can control the parameters of what's being used.
Yeah, I think I see that. I think there's a question there about setting the ethical bar that I think, is it Peter would like to go back to, just to circle back around on that one, please.
Yeah, I asked if I could. Really interesting in terms of who sets the ethical bar. To some extent, it's set by society, and we heard the Daily Mail test. Actually, the newspapers have always served a purpose, and in shaping public views and what's acceptable or not. And in World War II, the area bombing campaign was largely supported by the British public, especially in Coventry, the east end of London, and the most bombed places. But public acceptability started to wane towards the end. So it's a number of people set the ethical bar, but very specifically, I was quite taken aback 5 and 6 years ago when I was doing my research for the Reaper Force, and I got to sit in the GCS for loads of operations. And even on my first day, I was looking at a scenario, and I'm thinking, as an ethicist, I think you could take that shot. And they're saying, no, can't take it. And risk of collateral damage. And I was thinking, but the weapon that you're going to hit, that is a significant weapon. I think I would do that. And what was happening at the time was, legally and ethically, that crew, in normal circumstances, now they did not publish to me, and I didn't ask to see it, so I couldn't betray it, the rules of engagement. It would not have been controversial some years earlier in the Iraq War, for example. But what happened was the UK government, it doesn't matter which one, over the last 20 years has become extremely averse to collateral damage. But the laws of war and historic ethics of war allow civilians to be killed in war, as long as, and quoting the Geneva Conventions, not Geneva, quoting the convention, as long as the military advantage is not excessive to the harm that's done, the collateral damage, the civilian deaths. So ethics will allow a certain number of civilian deaths. Law will allow a certain number of civilian deaths. But UK government in recent years has been really reluctant to allow. So the political bar for civilian death and collateral damage has been higher than both the conventional military, legal and ethical bar. That's a very long to get to that, which is the key point. And that is, I think, that although we allow humans to make mistakes, it would seem that politically, for a while at least, AI is going to be judged against a higher bar than humans have been, both ethically and legally. And I'm not going to defend the rights or wrongs of that. It's a political and social cultural reality, but it is part of the challenge defense faces.
Yeah, and I guess the systems that AI grants us, the power that you can wield as the head of those systems, calls into question, you know, the anecdotal difference between a President Trump and a President Obama with regards to their worldview and therefore sort of ethical values and how they might solve some of those particular conundrums. Same country, same checks and balances, but a perhaps different, I might argue, approach to things, to issues such as collateral damage. And I think AI accelerates some of the conundrums, some of the problems that exist, and it requires of us a more definitive and well thought through answer that can match technology potentially. But anyway, now I'm beginning to sort of.
Adam, would you mind if I add one more thing, and that
Sure.
is the other half of the other part of my research is about psychological impacts of war, and particularly remote operations and police online child sex crime investigators and people who are psychologically harmed by things they see on screen, especially real time, especially things that they are powerless to prevent and are traumatic in and of themselves. I think we should also just be aware that the increasing autonomy does not remove psychological risk from operators. In fact, I would argue the counterintuitive point that if you're a commander who's just authorized this system with highly autonomous elements to go and carry out a function, and then it does something unpredicted and ends up killing a number of civilians, I think the mental harm to whoever authorized the release of that could be significant. So it's just a little pitch that psychological harm, including the signalers on this call, you see things that humans are not meant to see, and many will work through it and it's fine, but a number will be affected. Autonomy is not going to change that as long as there's humans in the system. So that's my little appeal on the psychological side.
Sure, thank you, Peter. Let's extend this a little bit further out then. What do we think? You know, I'm asking this question in the context of the Prime Minister's rather bizarre speech to the UN a couple of years ago when he was talking about, well, he started to talk about Terminators and then he ended up talking about phenols of whatever and Greek mythology. I couldn't quite follow his train of thought, but then I've struggled ever since, if I'm honest. But where do we see, what is the reality? You know, there are some significant potential advancements to be made. I'm thinking of some of the people on the school, the BAE systems. My father's best mate, when they flew jets together in the RAF, ended up being chief test pilot for Eurofighter at BAE Systems, director of flight operations. He took that job because he said it'd be very interesting because it'll be the last time that BAE Systems, for example, develop a jet with that sort of capability and can be bothered to put the weakest part of it, the human, inside the system. So where do we see, if that's what's happening, or maybe it's not, if that's what's happening in the air, what's happening in the sea, what's happening on land, how far does this go? Not quite to the Prime Minister's sort of, I don't know, sort of swivel-eyed view of what may or may happen with regards to science fiction, but what is the reality? How far is fiction in the advancement of this particular science? So that's a question for everyone really on the school that may or may not have a view.
Could I defend the BA Systems position, Adam? First of all, so I think there is a little bit of an obsession at the moment with autonomous solutions, and we hear all kinds of arguments around why do we need another manned fighter aircraft or inhabited fighter aircraft when the machines can surely do all of this better. Well, the reality is that artificial intelligence is still very narrow. We are a long way off before we have contextually aware artificial general intelligence that can perform the same sorts of functions as a human, including all of the ethical dimensions and considerations that that Peter made just earlier. But not only that, that is not what drives cost, right? What drives cost in a combat aircraft case is speed, payload, range, signature level, and of course, the sensors and weapons fit. That is the overall majority of the mass, the overall majority of the complexity and the cost. And therefore, why wouldn't you combine the best of both worlds of human and machine? And I think we will see this human machine teaming being the thing for some considerable time to come, before anyone thinks about handing over large scale functions to artificial intelligence. As much as I'm a fan of artificial intelligence and autonomy and done a lot of it, I can't believe that to be the right option in terms of delegating too much responsibility to what are narrow machines.
Sure, especially as I think in some of the speakers we've made the point that actually AI is particularly good at single tasks, multiple tasks, with lots of different things, lots of different data points coming in. Yeah, it's a huge amount of computing power that can deal with that, but that still overlooks that actually these decisions need to be made with all of that data, not with very good decisions about one particular aspect. Kirsten made the point about actually being sort of counter AI as a weapon, and how might that be developed, and how might that mirror the development that we're seeing currently with regards to this argument around autonomy?
Well, yeah, definitely. Because if you, for instance, I'll take the visual domain, you can have things such as the adversarial attacks. And you probably see them quite often on sort of news stories and things with autonomous cars, with the stop sign, and people put a little bit of masking tape over it, and then the machine reads it as like 40 miles an hour or something rather than the stop. And it's these sorts of things that can often be overlooked. If you think, if people are investing in tricking the systems, for instance, if you put a bit of or you paint a tank a certain way and it actually then sees it as a tree, things like that. If you overlook it from the day dot and just sort of put all the efforts into our capabilities, as it were, you could actually end up being at a disadvantage if these types of AI, be it in the visual, be it in just the data, you can still trick these things. And that's kind of a very visual domain, adversarial attacks. But there's all sorts of other attacks that can go on, which are quite different to sort of the generic way that we code at the moment. So things like poisoning attacks in the data. How do you know that the data that you've got and you're training on doesn't actually have vulnerabilities embedded into it, so that when it's actually deployed, it has that vulnerability? And I think when I sort of talk about counter AI, it's also looking out for that sort of vulnerability as well. And I just think it's a very keen point to have and to think about it.
Sure. Great. I was going to bring you in there as well, but you've got your hand raised. But I was going to ask you a particular question about ways of working, because you were looking at things slightly more broadly as well, adopting new ways of working to be able to make use of these technologies and advancements as well.
Well, I think this is a twofold response. The ways of working, you can, first of all, it's not just what you do with the output of the AI, and we always go back to the use case, and we always had human factors staffs involved in the design. It goes back to the actual design process. It's not just a case of sitting down and coding because data has been made available. Our DevSecOps team had a combination of data and architecture leads, test and verification leads, design managers, technical specialists, human factors team, security assurance coordinators, along with the DSTL embeds, and also the communication managers, those who are doing that transformation piece to say this is what the output would give you. And the reason being is, and Kirsten makes a very good point, there are many vulnerabilities in AI. We identified up front the physical system it sits on, the human in the loop, the data with the model drift and so forth. So all of these things can be sort of like mitigated or designed out. So eventually what the output would then do is then say to the end user, and we say, for example, when we actually deployed our capability last year, I think in a 30-hour planning cycle, 11.5 hours is saved straight away, just because the way in which we'd approach the data questions. And that garnered a huge amount of user buy-in. That was actually great for us to see with all the kind of operational analysis behind it. But that's because the design had actually got to the point of you can trust the output. And I think this goes back to a point on narrative. There is a great deal out there. You look at any of the kind of technical blogs or the news blogs in terms of what's been done. sometimes the way in which industry has said something in a very, said it in good faith, this is what this capability can do, this is what it's designed to do, it will get spun. It will be taken out of context. We always had a kind of joke in the team that we could guess the film somebody had been watching when they came in to say what they wanted to see. It was always pretty bad after something like Marvel or Mission Impossible had been on, because you get something fairly outlandish. By the same token, I can remember saying this to Patrick Sanders when we were doing a conference with him. You can get to the point at which, if you have the right data architecture and algorithms with the underpinning processing, you can get after some of this. It depends upon the legal constraints you face and the ethical constraints, ultimately the use case. So the ways of working for us, there's as many, I would argue, not just the operational space, which you're very focused on here, there's many back office functions and support functions which can be supported by AI. And I think there's a huge amount of utility because that helps generate and sustain the force. It's not just necessary, and that could actually lead to a much more efficient, optimized force when it deploys. And I think the one bit to consider from a kind of defense perspective here is that you're talking very much now multi-domain problem. You have data coming from all the different operating environments, the 5 domains, which has to come together and be synthesized and exploited. That's a challenge for good old kind of data fusion and analysis in the first instance, standfast AI. And I go back there, I think Kirsten's point in re-emphasizing you have a very narrow AI focus in some of these areas. So I think ultimately success begets success. But as we always pointed out in some of our distinguished visitors briefings, and in fact the briefings to wider audiences, AI is only as good as its last outing at the moment. If it piles in and it fails badly, the chances are people will get turned off for any number of reasons. They will actually start to, their risk appetites will actually decrease. They may start to turn away and then revert to type. So I think it's also something around a very controlled narrative, a very considered narrative, and actually maintaining the user's engagement all the way through that design process as well.
Yeah, and you made some really good points in there. Thank you. And also the opportunity, sometimes when we talk about these systems, we in our mind's eye, we're thinking of, unmanned vehicles unleashing missiles from above and raining down fire. But actually, there's a huge non-lethal application of these sorts of things that enhance what the military does that often gets overlooked. I think that we sort of, it's not the headline and therefore doesn't get talked about as much, but actually the connotations for that and the development of that could be massive. One of the questions that, again, I would like to put to all of you around this is actually to do with people, and that's twofold. There's one that's people with regards to who has the capability and skills to be able to ask the right questions that lead to better arguments around. Do we have enough people? Do we have the right sort of capability within MOD and armed forces? Are we confident that we're getting those sorts of people? Do those people look different to the kind of people that we've been recruiting? Maybe they're people who aren't naturally aligned to wearing the uniform and to operating within those hierarchical environments. This extends out into cyber as well as it does in some of these other technologies. Can we get those sorts of people? Then there's an ethical question. I think back to sort of examples of Project Maven. Goes to Google. There's where some of these technologies are developed. There's a Silicon Valley view of the world, which is, the internet is here to make the world a better place. Usually what they mean by that is for white men who can't get pizza and taxis. They've solved those problems. Some of the bigger problems that are facing the world today, perhaps less so, but there we are. So that's my question. Can we get people with the capabilities to be able to solve these particular conundrums and to add to the smorgasbord of talent that we need to be able to unleash the potential, sort of lethal and non-lethal? That's a pun intended. And what are the ethical conundrums do we think, therefore, with that sort of people and those sorts of capabilities as well? How does the MOD acquire this talent to unlock the potential of these technologies?
I mean, I can jump in there, being within the mod and having jumped from one service to the next. I think ultimately we need to understand the array of skill sets. And one of the things we had in setting up the program is there's an immediate focus by some of our stakeholders on having a data scientist. Great, get data scientists, but first of all, they need the data to work on when they arrive. They need the architecture, the target architecture. They need all the DevSecOps environments. So we actually thought laterally in terms of how would you set up the DevSecOps environments, get all those other skill sets in, and some of them are from very traditional areas. Signals have got an awful lot of them, but sometimes it's a service or cap badge agnostic. It's just somebody who is good at architecture, somebody who is good at testing, somebody who is good at developing training plans, and so forth. And then being able to come with no kind of baggage around it. Particularly if you give them the freedom to work in our program, we like to break things. It so happened I'd worked for both the vice chiefs and the previous guys, And I actually knew that we could break things, learn and move on. I've just seen somebody pop up by leveraging specialist reserve. There's so many different skill sets that come together. On the one hand, I went out and actually bought the data scientists in from outside. But when I then had, the twofold problem I had was I had people from outside defense who didn't understand how the military worked. So I had to take them on exercises. I had to take them to demonstrations and experiments, take them to Shrivenham to the Defence Capability Centre, so they understood. If you're going to talk about tanks, for example, how many people have actually stood by one, realize quite how big they are and how pokey they are when you get inside the turret, all this kind of thing. For my part, then I had people who didn't fully understand how data scientists and AI engineers spoke. So I sent the rest of the team, off myself included, on the Oxford AI programme. So that whilst we wouldn't be coders, far from it, we could at least all speak the same language. So I think there's a kind of, the model bring people in, but you have to invest in them. They can't just come through the door and then say, right, get on with it. You need to make sure they've got the right working environments, but also think very laterally in terms of building the right teams and sustaining the team. Also, I admit, keeping the people is the hardest piece in terms of the way which we contract people in, and also just losing them, they'll go back out to industry. In my case, I decided to retire from the army, but I did go across to another government department or a department within defence because I just wanted to carry on working in related subjects. Not quite this now, it's slightly different, but the same principle applies.
Yeah. What about others' experience?
Yeah, so I guess from a company perspective, we formulated a new master's program in applied AI about 3 or 4 years ago with Cranfield University, because when we looked at the market, there was a lot of data science, computer science related AI courses, but there weren't any courses which had systems engineering at the core, that had ethics, societal and regulatory elements included, cyber physical systems and so on, right? As well as the normal topics like statistical learning methods, data and analytics, and deep learning and all the rest of it, right? So all those things were in there, but we wanted something that was specific to defence that would allow us to upskill. And so in the first year of that, there was a cohort, I think, of 11 of BA Systems folk to pilot it. And we recognized that upskilling was probably a good approach, because these are people that already have a good defence understanding. They've spent time with the customer, some even reservists and so on. And also they understood systems engineering, the context, the architectures, the holistic design thinking and principles. And what they just needed was a boost in terms of the AI and the wider considerations that come with AI. And, at the end of the day, defense is up against it, right? Because, the folks coming out of university with AI related degrees are commanding huge salaries, and they're getting paid that, by the tech giants. And therefore we have to think very carefully about what the employment proposition is, because the defense industry isn't going to be paying £250,000 to 500 AI engineers, right? That's not going to happen anytime soon, I would argue. Things could get better, but ultimately we're never going to get anywhere near that. And therefore the employment proposition is really, really important. And there are things that you can do in defense which you just can't get anywhere else. I've been fortunate enough to sail on aircraft carriers, fly on helos, fly on test aircraft, legally drive main battle tanks and all the rest of it, right? All because I work in defense. Now, there might be an interesting helter-skelter and a giant beanbag in a tech giant's office. That's all very well and good, but that's not the sort of thing which excites most of the people in defense, I think.
And also on from almost what you were saying, but on the other side, sort of the user aspect, and I can't remember who was talking about it earlier, but as in sort of defining the question. I think there's been some events recently, the Forces Focus, which had the Navy and the RAF at the moment, and sort of inviting industry, SMEs, academia to all come together and sort of discuss not only just the issues, but also the questions of AI. And it also gave the end users insight into, we need to define what the problem is. What are we trying to ask? Because often it's, well, what can AI do? Well, it can do anything. What specific areas are you trying to solve? Is AI then the right way to go? So I think those sorts of events as well, from a user perspective, kind of shapes their mind as well as to, if we're looking to deploy AI, this is how we need to ask the questions to make sure we actually get what we want, rather than sort of say, what can AI do for us? And then somebody makes a problem up because they've got a solution for it. So it's kind of shifting that mindset as well.
Yes, I remember someone saying to me, "Congratulations, Adam! You've discovered you've made a cure for which there is no known disease," which was kind of a well-made point. Peter, you were going to leap in there as well.
Yeah, it was going back slightly to how does defence get the necessary expertise, and someone in chat has suggested the specialist reserve, which is one way. I think there's a cultural issue there. My son-in-law, who I will speak about in his absence, has, like Sheldon in Big Bang Theory, a PhD in theoretical quantum physics. I would trust him and 5 of his mates on a night with 17 pizzas, working from 6 p.m. till 6 a.m. in the morning, to shut down pretty much anything in the country you want shut down if they were so inclined. But and I hate to be too stereotypical here, but I'll take some of the Big Bang stereotypes. The individuals who live that kind of night owl existence for years, from adolescence through to university and continued adolescence into their 20s and 30s, it's not a mindset that tends to want to join a uniformed organization. So if their mindset can't be changed, it seems the mindset of the uniformed organization has to change. But they are the most conservative, small c conservative organizations I've ever belonged to or worked with. So that there are culture clashes. One other option is looking further afield in the Commonwealth, and my 3 co-investigators in the autonomous robotics project that I'm developing are 2 are from India, 1 from Sri Lanka, and they described to me how long and difficult it was for them to be able to come and bring this amazing robotics and AI expertise to the UK. So I think there's going to have to be some lateral thinking, some changing of attitudes, definitely some open minds. And for what it's worth, my money would not be on, I wouldn't put all my chips on AI. I would be investing a decent amount, like the Russians are probably doing, on how can I mess around with the electromagnetic spectrum to make as much of this irrelevant as possible, as quickly as possible in a contested environment, and turn it back to, as Kirsten mentioned earlier, a contest of mass that, like you've seen the Russians doing just now. So I think a lot more lateral thinking to be done, as well as straight developmental work.
It's always the emphasis that scare the crap out of people, I've noticed, in these sorts of things. You would have thought it'd be the others, wouldn't you? But there we are. I've learned that it's not.
That's what happens when you're around death a lot as a chaplain.
Yeah, well, true. I take. Yes, I defer to you on that point. My last point is one of education, and not just of the general public. Although we've seen, I think we've discussed that, private sector have learned that the more diverse the team, the better the outcome. And I think the same must be true in sort of military terms. But actually, when it comes to education, I'm talking about politicians. So politicians tend to use IT, AI, machine learning, blockchain as magic. So the previous Chancellor of the Exchequer can stand up and say, you don't need to worry about the Northern Ireland border because of blockchain, as if just by saying the word, magic happens and things and problems go away. And politicians of both sides of the house, all sides of the house, get seduced by the idea that the technology that we've been discussing this evening is going to solve problems, that you won't have to put infantry soldiers, boots on the ground, to go and deal with a problem like Ukraine, because you can do it by this sort of computer gaming magic, and therefore there's not going to be a kinetic, old school, shows my age, a kinetic problem that they're going to have to deal with. What are we doing as a community with regards to AI, speaking up to politicians so they can make better policy decisions? Or is that an AI solution that's in the offing?
Well, I guess Peter and I are members of the Defence AI Ethics Panel, which in some sense is overseeing all AI and autonomy adoption in UK defence as a as a sanity check, really. So we can provide our views and influence through that, and obviously through our network. So it's not just individuals on the panels. These are folk that will speak to their counterparts all over. So I've got counterparts in MBDA, in Leonardo, in Rolls-Royce, and a range of other companies that speak to about the AI topic on a frequent basis. So we can do that. We can also get involved in AI experts group. So there's one in Brussels with the ASD organization that represent European companies. So we provide papers into that on things like meaningful human control, which have fed into European Commission leadership and also European Defence Agency leadership as well. So I think we've all got a role to play in this, because I think it's in everyone's interest to get it absolutely right. Nobody can afford to make any mistakes here, and all of that I think filters through, into the politicians. But there's obviously a lot more that can be done and more angles at play as well.
Yeah. I was going to say as well, on from that, I think the misconception lies quite a lot everywhere, although obviously the politicians are one aspect, because what they say gets them put in the media, and then you have sort of that spiral. You also see it within companies, within industry, with people like to say these words without fully understanding what they mean, and that's kind of where that misconception, where AI can solve everything. Well, it can't. It's a tool. It can be used in certain applications. Other applications, the normal rule-based way would be much better. And I think what I try to actively do as well is to hold almost discussions like this to try and make it more apparent about what AI actually is. And when you get down to the fundamentals of it and people actually understand what it is, that whole misconception of, oh, it's magic, it can solve everything, like sort of slowly dissolves out. So I think that's kind of a key point. Yeah, absolutely. Look, it's over time. I'm going to ask Rob to come on in a second, but I'd like to thank, it's been fascinating. I could chat about, this is a particular topic of mine that I find fascinating, really interesting for all sorts of reasons. But Peter, Nick, Kirsten, Geraint, thank you so much for your time this evening. It's absolutely fascinating. I could continue on with this for some time. I'm going to actually ask our CEO, Rob Derry, to sum up, which seems particularly cruel, if I'm honest. Feels like we just sort of set fire to the piano and walked off stage. But anyway, that's the those are the cards that he's been dealt. He's going to have to play them. So thank you all so much. It's fantastic to have you all on board. I hope we get to do this again and similarly in the future, because we've hardly even scratched the surface. But I would thank you all again and ask Rob, who's just going to say a few words and sum up for us for this evening. Thank you all for your participation, and thank you everyone online for logging in and listening. I hope it's been I hope you've enjoyed it as much as I certainly have. So over to you, Rob.
Yeah, thank you, Adam. We'd originally planned for this evening to be an event that we wanted to be very special and memorable. So I was really gutted that we couldn't meet together and do something like that. But I have to say, gosh, that was amazing. I learned so much. But now I feel that I've got a very small brain in the presence of Kirsten, Geraint, Nick, and Peter, I must say. I'm sure Nick's comment about the size of bee brains was solely to make me feel marginally better and give me some hope. But anyway, everything we've heard this evening shows how the defence landscape is evolving at incredible pace, and the application of emerging digital technologies is really accelerating. As John Higgins said right at the outset, it's essential that for IT specialists more than ever to demonstrate professionalism and ethical integrity to the public, government, a range of partners, and also to each other. And as Major General Collier alluded, that's exactly why the MOD is so conscious about investing in its people, and why it's fully embracing industry skills standards as a foundation to professional development. It's really positive to see so many members of industry and academia here with the Royal Signals. And I say that because maintaining world-class capability needs collaboration and agreement on all those technical and ethical standards. I'm confident and excited that BCS's partnership with the MOD can make professional registration more than just an aspiration. And now with BCS, with its Royal Charter, our reason for existence is about making IT good for society. So I'm proud that together we're helping grow the numbers of people serving the country to gain professional standards and chartered status, and importantly, achieve the recognition that their skills and dedication deserves. Well, as I have a glass of chilled wine waiting for me, I'm not going to keep you any longer, so do enjoy the rest of your evening. The live chat's open for a little bit if anybody wants to use it. I just want to have a call out to Cara, Aaron, and the whole team who have put the event together. We really appreciate the challenges that you've had doing this. Thank you so much. Thank you all for attending. As Adam said, I hope we can all meet and celebrate a quality event properly next time round. Thank you so much. Good evening.